Hi, this is Mrs. LeBounty, and I am the 7th grade math teacher. I am going to be going over what we are going to be doing during our lives. Our live on Thursday, I should say. You can see that I have Hannah right there. Grammy is right here. And if I turn just slightly so, Solo's there, I promise. And Conway is over here. They're all sleeping, so this will be the perfect time to teach you about. Oh, me. In class, I always like to show pictures about me just so this everyone can get to know me a little bit better. So if you're watching this and that you're not in live, you can see it's me cuddling with Conway, and there's Solo, and Conway down here, and Hannah, and up here Solo's trying to steal my coffee. So here's the learning target. This is what we're going to be doing. This is the second day we're reviewing for the test that shall not be named. And this is TEAC 7.9C. I can determine the area of composite figures containing a combination of rectangles, squares, parallelograms, trapezoids, triangles, semicircles, and quarter circles. So pretty much you are finding area. In the live, we are going to be playing a GIM kit to review our multiplication facts because some of us are not allowed to use calculators on the test. We are going to review in class kick, and then I'm going to leave time at the end of the call to work in Buzz, or I'm also going to provide some IXL extra practice. So remember, the beauty of watching me teach here is that if I'm talking too fast, you can go in the little cogwheel and you can slow me down. Or you can make me talk faster because sometimes, I don't know, I talk a lot and I talk kind of slow. So here we go. I'm going to click past all this because my students like to show things about themselves, and if you're in my live call, I highly encourage it. But here we go. We're going to start day 2. So the flow of the lesson is going to be, we're going to relearn the topic in 5 minutes or less. Then we're going to practice the problem first, and then we'll see if we were correct. So what I'm going to do right now is I am going to play this 5-minute math video just to refresh us about what area of composite figures looks like. Now, this video is a little scratchy. I'm going to warn you at the beginning, but it will clear up, I promise. And the reason why I'm doing this is because I want us to practice watching and reviewing videos. So here we go.
Hello, and welcome to 5 Minute Math. Today we are looking at the 7th grade concept of area of composite figures, specifically how we can use the additive property, and we will do it in 5 minutes or less. So we have a strange looking figure here, and the problem is simple. How can we find the area of this composite figure? So as you see, we've got 4 different things we're going to have to deal with here. We've got a rectangle, that's the largest. So we need to find the area of this rectangle. I'm going to say area of a rectangle, that is going to be length times width. Then we've got this triangle right here. So we need to know how to find that. The area of a triangle, that's 1/2 base times height. Then we've got the area of this trapezoid. So it's a strange trapezoid. It's a right trapezoid because it doesn't have 2 slanted lines. It's just got 1. So I'm going to put the area of I'll call that TRA. I guess I'll make this TRI. That's 1/2. Then you got base 1 plus base 2, because those are different, times the height. So kind of like your triangle. And then we've got the circle, but it's not even a full circle, it's a half circle. So we're going to take the area of a circle, so that is pi r squared. Then we're just going to multiply that by 1/2, or divide by 2. Same thing. So let's see if we can start working these out, because then we're going to have to add all of them.
I'm going to pause the video. I know it's a little scratchy, but I am just kind of ignoring it. These formulas right here, I just want to point out, you do not need to memorize them. You do not need to memorize them. You will be given a star chart.
These up. So these are just units. We don't have any feet or inches or meters or anything. So let's start with our area of a rectangle. That can be the easiest. That's length times width or base times height. You can look at it either way. So really it's 15 times 5. So that's 15 times 5. And that's pretty simple. That's 75. All right, so our area of our rectangle is done. I'm going to put that at 75 square units. Let's deal with our triangle next. So we've got 1/2 base times height. So area of a triangle, let's put
He's
that
doing
right
this
there,
triangle right here.
is going to be 1/2 base times height. So 1/2. My base, they give it to me right here, is 4.
Mm-hmm.
And then they don't give me my height, but it is the side of this rectangle, and this side of the rectangle is 5. So we can say that this height right here is also the side of a rectangle. It is going to be 5. So times 5.
I'm going to pause it here. So I know there's no number here, but you have to be a math detective and look until you see a length that looks similar. This looks similar and it is 5, so that's where he got the 5 from.
So that's going to be 1/2. Let's collapse the 5 and 4. That's going to be 20. Half of 20. That's pretty easy. That is 10. So now I've got 10 square units right there, and we're halfway there. Now comes the kind of trickier parts.
Oh, my Lanza, I thought it cleared up, but I guess it didn't. So I am going to just like do this. I'm going to do closed captioning, and I think I'm going to turn it off, and I'm going to read as we go here. So he's looking at the trapezoid right now, and that's the bottom part right here. And he's writing the formula for a trapezoid. You take the bottom, which is a 6, you add the top, and this is where we also have to be math detectives because I'm noticing that it's a 5 and a 4. So you have to combine those together. He might not be saying, oh, he is saying that. Oh, I'm magical. So he did 6 plus 9. Oh, my eyes are a little dry. And he's just talking about the height of the trapezoid right now. Usually they would have a dotted line, but because it looks like this, it's from top to bottom. He's noticing that the height is 5. So he wrote down everything. Notice how he writes the formula all out, and then he replaces every single part of the formula. So he's solving it. He's saying, okay, 6 plus 9 is 15. 15 times 5 is 75. And then you have to take half of 75, which is 37.5. So far we have the rectangle, we have the triangle, and we have the trapezoid, and now you need the circle. And that's pi r squared. So the circle has a diameter of 4. Radius is half of that. So that's 2. So when you put it in the formula, 2 squared is 2 times 2, which is 4. And then you're going to see here, he quickly added up everything. That's what you have to do. You have to add up the 75, the 10, the 37.5, the 12.56. And he got a total of, and I forgot to mention with the circle, he had to cut it in half because there was only half a circle. There we go. That was the total. So now moving forward in class, this is a problem from last year's STAAR test. A composite figure is made up of 2 rectangles and a right triangle. The figure and its dimensions in centimeters are shown in the diagram. What is the area of the composite figure? So I am going to show you, and hopefully this works. And if it doesn't work, I apologize. I am still playing around with Screencastify here. In class, I'm going to suggest, and this is a test taking strategy, always take a look at the problem and make observations. Notice things. So I highly recommend, I'm going to pause this recording and I want you to notice and make some observations. So, for example, I'm noticing that there's a rectangle right here. I'm noticing there's another rectangle right here, and there's a triangle. So you might have to say to yourself, okay, I need the area formulas for a rectangle and a triangle. So I suggest pausing this, trying the problem out, because that's what we're going to do in class. Once you have the answer or you think you have it, you can start the video again. So here we are. Here's the video. I don't think this is scratchy, so I'm going to go ahead and play it.
Hello, and welcome to 5-Minute Math. Today we are looking.
And I'm going to just demonstrate some things while we're watching this. This is just, again, another test taking strategy. See the cogwheel? This is what I'm talking about. When you're watching a review video or even a learning video, you can change the speed. So I'm going to make him talk a little bit faster.
Unpause it, and we will look at our answers together. So we have this composite figure. Looks like it's two rectangles and a right triangle.
That's a little too fast for me.
And we need to simply find its area. All right, so in case we need it, we've always got our reference chart up there. And since we're dealing with two different types of.
So again, when you're taking the STAAR test, you are going to have all of the formulas available to you. So he just, I'm showing his video because I like it here. You can see all the tools, and he just clicked, and that's where it is.
Area. Let's look up here. You'll see them towards the top of the screen. So the triangle is going to be 1/2 base times height, and then my rectangle is going to be base times height. So it's always easy to kind of
I'm going to
remember that
change
the
his voice
triangle is
there
half
because I'm
of
going
the
to let
rectangle.
you play around with
And
it
then we
on
can
your
take
end.
any rectangle, any quadrilateral for that matter, and turn it into two equal triangles. So you just take that and you cut it in half and you're good to go.
What is he
All
doing?
right, so let's simply do this. Let me
Oh, he
scroll
changed
that down a little
it
bit
so
so I
his
can
graph
see
paper
my
so he
four
can draw.
options. And I just want to find the area of each of these and just add them up. That's what we do when we have composite figures. So I'm going to do area equals, this is my base times height. This is going to be my base times height. And I'll change my color here. And I'm going to say 1/2 base times height because my triangle is going to be a slightly different one. So let's start with my two different rectangles, right? So I've got my 30 and my.
I'm going to pause this for a minute because maybe everyone's different, but maybe you did the triangle first because you like finding areas of triangles. Personally, I think rectangles are a little bit easier because you're only doing two things. But again, it's entirely up to you.
8. So 30 times 8, that's going to get me a 24. I'm going to put that over here so I can stack them up and go ahead and just add them. 24 with that extra 0 because that's what we do when we multiply by multiples of 10, 100, 1,000. We just multiply the digits that are not 0. 8 times 3 is 24, and then add the number of zeros at the end. So I've got 240 square centimeters. That's pretty easy. 240. Let's do this other one. I've got the 6 times 12. All right, so 12 times 6. And that's just a basic fact, right? 72. Let's make sure I line them up. Square centimeters.
Ah, that's a good. Okay, so he on the STAAR test, you can change the background to graphing paper, and that's what he did. But then you can change the transparency, meaning you can make it darker or lighter, because some people might not like writing on just white space. The graphing paper makes it so that he can line up the digits. Because I know when I'm adding decimals, I have to line up the digits.
All right, 72. Now the only quote unquote trick in this problem is my triangle. Well, first off, it's a different formula. It's 1/2 base times height. And secondly, it looks as if I don't have any measurements at all, but it is a right triangle. So what does that tell me?
Again, being a math detective, I'm going to look at this line and I'm going to go, "Tick, tick, 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 tick." Oh, look at that. It matches up. And then I'm going to look at the bottom and go, "Tick, tick, 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 tick." Oh, it matches up.
So when it says it's a right triangle, and I also know it's a right triangle because it's got the square right there in one of its angles, that means that a side equals a height. So one side equals my height. Because in normal triangles, right, you're going to see something like this. If you see a triangle like this, you can't use any of the sides as the height. And what you would end up needing to do is they would end up giving you like a dotted line like this
That's
to
good
show
to
you
know.
what the height is, because you can't use one of the sides. But since it is a right triangle, you can actually use this side right here as the height. So if I know that side, I know my height. Well, if this side right here of the rectangle is 8, then that is also 8. Okay, so it's going to be 1/2. My height is 8. Need to figure out the base. Well, seeing as how this side right here is 6, then I can say that base is 6. So that's it. All we got to do is just take the height and the base of these two rectangles and use them as the height and base of this triangle. And so that's going to be 6. Right? So how do we want to do that? Well, you can either multiply 1/2 times 6 to begin with, right, and say that's 3 times 4. So
Do
that's
6 times 8.
uh,
Let's do it.
3 times 6, and that's going to make that 3 times 8 is 24. Many different ways to do that, right? Or you can do 6 times 8 is 48. Half of 48 is 24. You can even do
That's what
the
I did.
half times 8 gets you 4. 4 times 6 is 24. Many different ways to do that. They all end up with 24. So that's 6. That's going to be 11, 13, 336 square centimeters. The answer is A.
Alrighty, so that was that.
Hello, and
So for composite figures, there's adding all of the shapes up. And that's called the additive property. We're just adding them all up. You're going to have some questions that are going to require you to subtract. So we're going to go ahead and watch this video on how to find areas of shapes when you have to subtract.
hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of area of composite figures, specifically how we can find the area if sections are removed, and we will do it in 5 minutes or
Oh, it
less.
looks like a mask, doesn't it?
So we have a rectangle here. Let's put some dimensions on this rectangle. So let's say we've got a rectangle that is 18 feet by, let's call this 10 feet. And a typical problem we might see is, what is the area of the shaded region? Now there might be some type of story problem that goes along. These two are congruent circles,
They're
so they
similar.
might only give you the
They're the same.
dimensions of 1. And so let's say they give you the diameter of one of these circles. And so we will say this diameter right here is going to be, we'll call that 8. Now we'll call that 7 feet.
Always going to be tricky and use the number 7.
And so our question is, if we wanted to find the area of the shaded region, so there might be a story problem about painting something and,
At this point in the video, I would pause it and you could try it. The shaded is that dark gray part. You want to find the area of that region. So go ahead and try it out. You might not even have the complete answer. You might have part of the answer or a little bit of the answer, but just try your very best and then resume the video.
excluding out these circles, which might have been upside down paint cans, some reason why you can't just do 18 times 10. So if we did 18 times 10, that's going to be the area of the rectangle. So that's length times width, right? So that's going to be 18 times 10. That's super easy. That's 180. We've been doing that since 3rd grade. So the area of the
Really?
rectangle equals 180 square feet. And that will be, if this was a multiple choice test, that will be one of the answer choices. Much too easy. We
They will try to trick you on that test. Be careful.
didn't shade in, or we didn't paint or color or whatever we're thinking of these two circles. So we need to find the area of these two circles and subtract them. So now we've got to think, okay, what is the area of a circle? Remember, the area of a circle equals pi r squared. So we don't have the radius, but we have the diameter. Remember, the diameter equals double the radius. So if my diameter equals 7, 7
Just cut it in
equals
half.
2r. If I want to
Diameter, we don't want that.
figure out what
Distance.
my
No, no, no.
radius is, I am just going to divide both sides by 2. Just cut that in half. All right, so my radius now is going to be, and I'll kind of draw that in over here, 3.5 feet. All right, so I've got 3.5 feet as my radius. That's going to be helpful.
Mm-hmm.
So now I need to do just a little bit of calculation here.
Just tiny
I
bit.
want to find the area of one of these circles, and then I'm just going to double it because there's two different circles. So pi r squared. So area of a circle equals pi r squared. And so now we have some of these numbers here. Pi is going to be 3.14.
6852108.
But first we're going to have to square our 3.5. That's our radius. All right, so let's go ahead and do that. Let's see if we can do that right here. 3.5 and
That's me doing it.
3.5. Remember, it's the number times itself. It's not the number times 2. So that's 25. That's 15. That's 17. Get rid of that. That's a 15. It's a 9. That's a 10. All right, so we've got 5, 12. That's 2, 1. We've got 2 digits behind the decimal in our factors, 2
Okay, so
digits
like a
behind the
review on how to
decimal
multiply
in our
decimals.
product. So 12.25 is going to be, let's go ahead and just add that right here, 3.14 times 12.25. And we can do that long ways, or we can use a calculator. And so it's 38 and 465 thousandths. So if I wanted to double that, remember there are two circles. Let's just go ahead and double that.
So much
Let's
work.
see what our combined area of our circles are. That's 13, it's 9, 16, that's 7. All right, so 76.93. That's both circles together. Now I need to subtract that from my 180, and that's where it gets difficult. So I'm going to add my 2 decimals there. And if I do this with a whole bunch of regrouping, we are going to see that
Oh
this
my
area is
goodness.
going to be 7 hundredths, 103.07, or 103 and 7 hundredths square feet.
Look at all of that work. Wow. I want to take a picture of it and put it on my fridge. So now moving along here.
Hello, and welcome to
Oh, I'm going to move my little head here. My head is gone. Which measurement is closest to the area of the shaded portion of the figure in square feet? So in class, we're going to do the same thing. I'm going to give maybe 3 or 4 minutes and have you try this. Now remember, if you are stuck, you could at least try part of the problem. You could write down everything you know. So for example, I notice that the shaded portion is a circle. So I will need the circle formula. I notice that the rectangle in the middle is a rectangle, so I will need the rectangle formula. Go ahead and try it out. If you think you have your answer, great. We're going to go ahead and see if we were correct. Now I'm going to demonstrate a skill here. I am not going to play this entire video. What I'm going to do is I'm going to pretend that I think I have my answer. I'm going to pretend that my answer is 314 feet. Okay.
Hello, and
And
welcome
I'm
to
going to mute him for a minute and I'm going to scroll to the end. It's okay to use these tools.
78.5. That's if we just found the area of the circle on its own. They didn't give us a 48 as an option because that doesn't make much sense.
Okay, so it looks
The
like
answer
the
is D.
final. Oh, he said it and it went too fast.
Hello, 8.5. That's if we
The final
just.
answer in this solution is 30.5. So if you did that and got that answer, where's my, oh, I'm going to bring myself back. If you didn't get that answer, then I recommend going back to this video and watching step by step what he did. I will include the video in the Nearpod presentation so that you can go ahead and watch it. But I'm not going to sit through here and have us watch it again. I'm not going to do that. So here we go. In class, if I have students that are all done early, like there might be some students that did not need to watch all of that. Maybe you had the answers already. Well, then I'm going to give you some extra practice in IXL so you can practice this concept in more depth. I will also have this in my resources so that at any time, any day, you can practice. Thank you so much for watching this. I know it was a lot of work and sometimes it can be boring, but sometimes we gotta do what we gotta do. And hey, at least you have LaBounty here to keep you smiling. And at least my dogs didn't bark for this whole presentation. Thank you and have a fabulous day.